Okay, so in this video, we're going to be talking about properties of exponents and how to use scientific notation when it comes to properties of exponents. Now, before we take a look at our examples, we first want to look at the format that scientific notation has to be in. You can see that m, being our number out in front, has to be greater than or equal to 1 and less than 10. If it is not greater than or equal to 1 or less than 10, we are going to have to fix that, and I will show you how to do that. And then x, being your exponent, has to be an integer. So again, you couldn't put like 7.5 for an exponent there. It has to be an integer, right? And so we're about to jump into these examples, but before we do, just make sure you do have knowledge of properties of exponents, because if you don't, none of this will make sense. Luckily, I do have a video on properties of exponents. I'll go ahead and link it below. That way you have access to that content. But again, assuming you know how to do properties of exponents, let's go ahead and take a look at our first example. So here's our first example. And whenever you are dealing with properties of exponents and you're dealing with scientific notation, it's pretty straightforward because you're going to be doing pretty much the same thing every single time. And the first thing that you want to do is you want to figure out what your m is going to be. So for example, your m value right here is 9.5, and then your m value right here is going to be 4.6. It's telling us to multiply. I can see that right here. So before we even worry about the exponents right here and here, I'm going to focus on 9.5 and 4.6, okay? So in your calculator, you're going to do 9.5, and then you're going to multiply by 4.6. When you do that, you get 43.7. So I'm going to go ahead and write 43.7. And again, we know that this number here has to be greater than or equal to 1 and less than 10, but we'll fix that after. And then I have times 10 to the power of. Now think about it. I have a base of 10 here and a base of 10 here. I'm multiplying, meaning I can add the exponents. So all you're going to do here is do 5 plus 4, and you're going to get 9. So I put 9 here. Now that is our answer, but it's not going to be our final answer because again, we want to make sure that our m value right here is greater than or equal to 1 and less than 10. Meaning I'm going to have to take this decimal point right here and move it over to the left. Now, if you do that, how does that change your exponent right here, which is 9? Well, I'm going to have to go ahead and add 1 to that, making it 10. Because remember, originally that decimal point was right here, telling me to move it 9 to the right, okay, because the 9 is positive. But if I move it over 1 to the left, I don't want to change the number, right? So that means I'm going to have to add 1 to this exponent to make sure that the number is not in fact changing, right? So for example, you're going to put 4.37 times 10 to the 10th power. And this is now done. Okay, so there it is. All right, let's try another example. So here's our next example. Same thing, we're dealing with multiplication. So our first step, let's take care of m being right here and here. We're going to multiply and see what we get. So we're going to do 6.96 times 4.6. When you do that, you get 32. So I get 32.016. Okay? And now I'll have times 10 to the power of, again, I have a base of 10 here, a base of 10 here. I'm multiplying, I add the exponents. So -1 plus 8, that will give me positive 7. So I get positive 7. And now from here, how do I write my final answer? Well, again, I have to take this decimal point right here and move it 1 to the left, okay? Meaning that's going to increase the value by 1 on my exponent. So now I'll have 3.2, and then I'll have 0, 1, 6, and then times 10 to the 8th power, okay? And that's going to be it right here. We're done, all right? So again, my m value here is greater than or equal to 1 and less than 10. I'm all set. All right, let's go ahead and try another example. So here's my next example. This time I'm dealing with division, but again, I'm going to follow the same order that I was doing before, and I'm going to take care of m here and m here. The only difference, I'm not going to multiply them, I'm going to divide them. So I'm going to do 6.2 divided by 5.05. When I do that, I get 1.228, and again, I'm just rounding to the nearest thousands here, okay? And then I'll have times 10 to the power of, well, look, I have a base of 10 here, a base of 10 here. I'm dividing. This time I don't add, I actually subtract them, right? Because I'm doing division here. So if you have the same base and you are dividing, you want to subtract those exponents. Now be careful here. You're doing -3 minus 6. That's going to give me -9. So I actually get -9 here, okay, for my exponent. Now look at m. M is greater than or equal to 1. It's also less than 10. I don't have to do anything here. I'm done, okay? Here's my final answer. All right, let's try another example. So here's our next example, another division problem. So again, we're going to take care of 8.56, then we'll take care of 5.2 and go from there. We're going to divide them. So I'm going to do 8.56 divided by 5.2. When you do that, you get 1.646. And again, I'm rounding to the nearest thousands here. That's fine, right? Then I have times 10 to the power of, again, I have a base of 10 here, a base of 10 here. I'm dividing. That means I subtract the exponents. So I'm going to have -4 minus 5. That will also give me -9. So I'm going to go ahead and put -9 here. Okay. And that's it. I'm done. My m is greater than or equal to 1 and less than 10. I don't have to do anything else here. So I'm going to go ahead and box this in here. And that's it. All right, let's try 2 more problems. So here's my next example, and this one's a little bit different than the multiplication problems and the division problems because this is a power to a power. So essentially what you have to do here, you have to take this exponent of 5 and you have to apply it both here and here, okay? So essentially you're going to do 5.35 to the power of 5, and we're going to see what we get. And then we're going to take care of this power right here after, okay? But let's take care of m first. I'm going to do 5.35 to the power of 5. So again, 5.35 to the power of 5. And you're going to want to use your calculator here. So when you plug that into your calculator, you should get 4382 and then 0.974. Again, I'm going to round the number to the nearest thousands. That's fine. Now I have to do 5 times this -3 here. Okay, so I'll have times 10 to the power of, well, -3 times 5, I get -15. Now we do have an issue here. I cannot leave this number like I have here, okay? So we have to take care of it. Meaning I'm gonna have to go ahead and take this decimal point here and move it to the left 1, 2, 3 times, right? So then I'll have 4.38297.4, right? And then times 10 to the power of, well, how do I want to write it? So I actually moved the decimal point over 3 places to the left. And again, remember this negative right here is telling me to go to the left. So I technically have already gone to the left 3 times, meaning this is actually going to increase in value here. So instead of being -15, it's now going to become -12 because again, I've already gone 3 places to the left. So it's going to be -12 now. And again, I want the number to stay the same, right? I don't want the number to change. So that's why it's now going to become -12. And that's it. So this problem is now done. All right, there's my final answer, right? All right, let's go ahead and try one more example. So here's my next example. I have another power to a power. So first step, I'm going to take care of this right here. And then I'll take care of this right here. So I'm going to do 3.13 to the power of 6, okay? When you do that, you get 940. So you get 940.299. Then times 10 to the power of what? Well, 2 times 6 will give you 12. So again, this is an issue right here. I have to make sure that this m value here is going to be greater than or equal to 1 and less than 10. I have to take this decimal point here and move it 2 places to the left. How is that going to affect my exponent now, though? Well, again, it's positive. So I'm actually going to have to add 2 there in order to balance it out. So now it's going to be 9.40299 times 10. And then again, I said I'm going to add 2 to the 14th power. Okay? And there it is. Now this problem's done. Okay? So go ahead and box it in. And that's it. Okay, so that is properties of exponents when you're dealing with scientific notation. It's pretty straightforward. All you have to remember is that your m value, and again, that is the number out in front, has to be greater than or equal to 1 and less than 10. And again, that's something you can take care of once you're done with the problem. And you really just have to know your properties of exponents here, okay? And so again, if you are shaky on your properties of exponents and you want a refresher, I did put a link to the video that I did on properties of exponents below. That way you have access to that content. And that's pretty much it. So I hope that you learned something from the video. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.